All right, section 3.5 deals with functions and the different types of them and classifying them in different ways, and also with shifting and stretching or compressing them. First off, we'll talk about even functions. An even function is a function that is reflected over the y-axis. And in an even function, or if you want to prove a function is even, then f of the opposite of x is going to have the same value as f of x. And so, as an example, if 2, 8 is on the graph, then a negative 2, 8 will be also. Or if you had a negative 2, 8, then if it's even, 2, 8 would also be there. So here's a function, f of x equals x squared plus 5. Is it even? Well, to figure out if it's even or not, let's figure out what f negative x is. And when we substitute a negative x into this, it becomes a negative x squared plus 5. And when you square a negative, it becomes positive. So then finally it becomes x squared plus 5. And since this and the original function are the same thing, is it even? We would say yes. Now if you were to sketch a graph of this function, x squared plus 5, it would be here. And it's reflected over the y-axis. That's why it is even. If we had a parabola that was like this, it is not even because you cannot reflect it over the y-axis. So looking at our second example here, proving or trying to prove or find out if it's even or not, again, find out what f of negative x is. And you would get a negative x squared minus 3 times negative x plus 2. Squaring a negative would get you a positive x squared. A negative 3 times a negative x is going to be a plus 3x, and then plus 2. And now this function is not the same as that. And so therefore, we would say no, it is not even. All right then. Second type, it's not an even function, it could be an odd function. An odd function reflects around the origin. The coordinate 0, 0. And it says that if f of negative x is the same function as the opposite of f of x. And so as an example, if 2, 8 is on the graph, then a negative 2, negative 8 is also. Or similarly, if you had, like, say, a negative 3, 6 is on the graph, then 3, negative 6 would be. So in proving odd, you still have to figure out, you have to do two things. One is figure out what f of a negative x is, just like you do with even. And when you substitute that in, you would get a negative x to the third minus 3 times a negative x. Cubing a negative would leave it as a negative x cubed, and a negative times a negative is a positive 3x. Then you also have to figure out what the opposite of f of x is. So that means taking the opposite of the whole entire function. And the opposite of x cubed is a negative x cubed, and the opposite of a negative 3x is a positive 3x. Now you look at these two things. Are they the same? In this case, yes. So is it odd? Yes, it is. Second example would be this one. And here, if we take f of a negative x, we would get a negative x cubed plus 2. And then that turns into negative x to the third plus 2. Now then, if we take the opposite of the whole thing, that would be the opposite of x cubed plus 2. And the opposite of x cubed is a negative x cubed, and the opposite of 2 is negative 2. Now, are these two things the same? No, they are not. So this one is not odd. And so now, looking at some other things with functions, and we'll use the absolute value function to look at the rest of this. The absolute value of x, if we were to graph it, putting in some coordinates, at 0 you would get 0, at 1 you get 1, at 2 you get 2, at a negative 1 you get 1, and at a negative 2 you get 2. And so our graph would be coordinate there, and then it would go up 1 and over 1 that way, and up 1 over 1 that way. The slope of this half of the absolute value is 1. The slope of this absolute value on this side, half of it, is the negative 1. The vertex is at 0, 0. Now then, if we want to shift a function, it would be something along this line, f of x equals x plus 3. When you see this, because it is affecting x, anything that affects x, it moves it in the opposite direction. So this would actually shift the graph or move it left 3 places. So instead of our vertex being at 0, 0, it would be at a negative 3, 0. The slope of this side would still be 1, and the slope of this side would still be a negative 1. Now if you wanted to look at that as far as coordinates are concerned, if you're not following, so if you stick a 0 into this, you would get 3. If you put a 1 in, you would get 4. A negative 1 in would get you 2. And negative 2 would get you 1. And a negative 3 would be 0. And a negative 4 would be 1. And those are all those coordinates on that. Our second function here is f of x equals x plus 2. When it's not with the x, then that's affecting the y values. And when it affects y values, it moves in the same direction as what is there. So this will move up 2. And so instead of being 0, 0, it would be up here at 0, 2. And our slopes would still be 1 on this side and a negative 1 on this side. Looking at it as far as coordinates are concerned, substituting a 0 in would get you 2, a 1 in would get you 3, a negative 1 would get you 3 as well, because the absolute value of a negative 1 is 1 plus 2 is 3. Now then, if you had f of x equals the absolute value of x, and it said find out what happens to this function where you have x minus 1 plus 5, what that would mean is, if you were to bring this over into this, you would have the absolute value of x minus 1 and then plus 5. The minus 1 would shift your graph to the right 1, and the plus 5 would shift it up 5. And so then on your coordinate plane, you would be to the right 1 and up 5, and then you would have your v, still slopes of 1 and negative 1. If the original function was x squared, the same things would happen. It would still go to the right 1 and up 5, and you'd have your vertex right here at 1 comma 5. But now, because it's x squared, it would be a parabola and do this. The other thing that can happen to a graph is it can be stretched or compressed. All four of these things are either going to stretch or compress the graph. Okay, with this first one, it is 3 times f of x, and whatever f of x is as a function, you're going to take 3 times all of the values. So because it's not in here with the x, it's outside of it, so it is going to affect the y's, which means it's going to be whatever is here. So it's going to multiply your y values by 3, and so it's going to stretch vertically by 3. This one here, half times f of x, again, it's the same thing. It's outside of the function, so therefore you're multiplying by a half. And this would be saying, if you can say it one of two ways. You can say it shrinks or compresses. Now, when it shrinks or compresses by 2. You could also say it stretches by a factor of a half. Our third example here is f of 2 times x. Now here it is affecting the x values, and just like with our addition and subtraction, the opposite thing is going to happen. So this is going to be multiplying x's by a half. And so it's the same thing. It would shrink horizontally by 2. And finally, you have f of x over 4. So here we are multiplying by by 4. So we are going to stretch horizontally by 4. And you could get any combination of all of these different things in one particular function. And then you just have to apply everything that they have given you. Finally, there's the greatest integer function, which in this book is written with kind of a double bracket type of thing on both ends of it. In some books you'll see it this way. Other books you may see it like this. Either way, the greatest integer function means the largest integer that is less than or equal to the value. So for these examples here, greatest integer of 1.5 is the largest integer that's less than this would be a 1. For 2, the largest integer that's less than or equal to 2 would be 2. For 2.8, it is also 2. For 1.9, it would be 1. And for 2.3, it would be 2. Now, in graphing this, it's called a step function because it looks like steps when you graph it. You would have a closed circle at 0, and then it would go to there, and at 1 it would be an open circle. And then up here at 1 it would be another closed circle, and over until you got to 2, which would be open, and then it would jump up to 2. And then from 2 to 3, another open circle, and so it continues on like that forever. And then finally, all of the shifts and things can happen to this. If with the stretch, I mean right, left, up, and down, we're just going to look at a couple of different stretching types. If we have 3 times the function f of x and we're dealing with this greatest integer, this is going to, the 3 is going to affect all the y values, so it's going to stretch it by a factor of 3 up and down. This is going to stay the same here, but then the next value up is going to be here at 3, because it's going to multiply that by 3, and then over to there. 2 times 3 is 6, so then it's going to be up here at 6, and over 1, and then down here at a negative 3, and so on and so forth. And this other one, half of x, this is going to stretch by 2, or you're going to multiply all of the x values by 2, so that's going to stretch it horizontally, and so now instead of going from 0 to 1, it's going to go from 0 to 2. And then up here it's going to jump up, and then go from 2 to 4. And same here, 0 to a negative 2, and an open 1, and all the way over to a negative 4. And that is everything from section 3.5.